Hi, welcome to the lesson on scientific notation. I'm going to approach the start of this topic just a little bit differently. So, I'm going to start off by asking some questions. Take a look at this number here. Would you say this is a large number or a small number? What about this number? Would you say this is a large number or a small number? Question two. Will the exponent be positive or negative on these numbers? Okay, so just be thinking about those for a moment. Another question I would like to ask is, how many places will the decimal point move? How do we rewrite the numbers in scientific notation? All right, so all of these questions we're going to address. All right, so taking a quick look at this number here, which is 99 millionths. This number represents the diameter of a human hair, as you can see here. So this is not a very large number, is it? This number is 10 trillion. And a fun fact, did you know that there are about 10 trillion galaxies in the universe? Now, taking a look at these numbers, I know you're saying to yourself there has to be a better way or an alternative way to write such small numbers and large numbers, right? So we're going to definitely be covering that in this topic of scientific notation. All right. So let's go ahead and move on. Let's actually talk about these numbers for a moment. Okay. So let's go to the next slide here. So let's take the number 99 millionths. So let's go ahead and do that. So we have 99 millionths. All right, so taking a look at this number, we already said that this is a very small number, okay? And since this is a very small number, what I would like to state is that the exponent on the power of 10 will be negative, okay? So that's very important for you to get. So let's just say how that is determined, okay? So since this number is really small, then it is a number that's written between 0 and 1, but not including 1, all right? So I always like to take a look at the whole numbers position here, okay? So this number here will definitely have a negative exponent, all right? Now, the question we need to ask ourselves now is, how many places will the decimal point move, right? So what we need to do is rewrite the exponent, but first we need to ask where this decimal point is. And so it is right here currently. Then we need to count how many places the decimal point needs to move until there's just one digit to the left of the decimal point, all right? So let's go ahead and do that now. So currently our decimal point is here. We need to move it to where the first digit will be to the left of it. So that's 1, 2, 3, 4, 5. All right. So take a look. We have a decimal point here, and what's that number immediately to its left? And it's 9. So let's get rid of these zeros here, and we are going to rewrite this number as 9.9 times 10 to a negative power, and that negative power will be 5, okay? And the reason why is because we had to move this decimal point 5 places to the right until there was one digit to the left of that number, okay? So that's what brought it 9.9 times 10 to the negative 5th power. Okay, so now let's go ahead and take a look at 10 trillion. All right, so 10 trillion is written as this. So all right, so thankfully there are alternative ways to write really large numbers and really small numbers. Okay, so we're going to approach this the same way. So right now our decimal point is here. So there's always an imaginary decimal point here, okay, on these numbers like this. So what we're going to do is the same thing as we've done with the smaller number. We're going to take a look at where the decimal point is, and we know the decimal point is here, right? We know that our exponent will have a positive exponent since we're working with a very large number, okay? Then we need to rewrite the exponent. So since we know our decimal point is here, we need to move it just one digit to the left of this decimal point, okay? So let's go ahead and do that now. So we have how many spaces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually, I skipped one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that's 1.0. Okay, so sometimes you'll see it written like this, and other times you'll see it written as just 1. Okay, but we always say to get rid of the trailing zeros. Okay, so the next thing we're going to do is rewrite this in scientific notation. All right, so which is 1 times, and this power will be positive because we're working with a very large number, and we had to move the decimal point 13 places, right, until it until it hit a digit before or actually to the left of it. So in this case it's 1, right? So we have 1 here, so it's 1 times 10 to the 13th power. We had to move the decimal point 13 places. Okay, so there's our final answer there. So this is the same as this. Okay, so see that? And I bet you already know what the definition of scientific notation is. All right, so of course scientific notation is just simply a shorthand way to write a really large number or even a really small number. So let's go ahead and talk about this more in depth, okay? So let me go ahead and erase this. And when writing numbers in scientific notation, we use powers of 10, right? For example, 10 cubed. And this consists of exponential expressions of negative numbers or even positive numbers. So let's say we have 10 raised to negative third power as well. Okay, so let's take a look at 10 cubed for a moment. So the exponent on 10 is simply telling you how many zeros to write after it, right? So in other words, we have 1 0 already, so we need 2 more zeros for this to equal 10 cubed. All right, so as you can see, what we're really doing is taking the base of 10 and we're multiplying it by itself 3 times because of the exponent of 3, which is equal to 1,000, right? Because we have 3 zeros in here, and then we have 1 times 1 times 1, which is equal to 1, which when you bring that together is 1,000. Okay, so hopefully you were able to see that. Now let's take a look at 10 cubed. Okay, so 10 raised to the negative third power. All right, so if the exponent on 10 is negative, as you can see here, It's simply telling you how many zeros to write before the 1 with the third 0 in the whole number's position. Okay? So in other words, this is going to be written as this third number being in the whole number's position, right? Which is here. And then we have 2 more zeros. So this is simply saying 1,000th. Okay? So if you remember our previous lesson on zero negative exponents, we talked about how we are taking the multiplicative inverse or reciprocal of this number. So that's the same thing as multiplying 1 over 10 times 1 over 10 times 1 over 10. Okay, which equals 1 over 1,000. Okay, so I just wanted to make sure that was made clear. All right, so let's go ahead and move on. So let's just say that you have 8.47 times 10 raised to the 8th power. Okay, so let me go ahead and rewrite this. 8.47 times 10 to the 8th power. So 10 to the 8th power is really saying that we already have 1 0, but we need to add an additional 7 zeros. Okay, so we have 1 0 here. We need 7 more. 1, 2, 3, 4, 5, 6, 7. All right, so this number here, as you can see, is comparable to 10 raised to the 8th power. Okay, so 8.47 actually is equal to 847 million. All right, so you're taking out the decimal point here, just rewriting it as 847, which is being replaced by the 100 here, and filling in the rest of the zeros. Okay, but let me tell you what's really going on here. So what's really going on is that you're taking the decimal point and you're moving it 8 places to the right. All right, so let me show you what I mean. So let's just say, let me go ahead and erase this so we have more room here. Okay. All right, so we have 8.47. Okay, and we're going to take the decimal point and we're moving it 8 places to the right. Okay, so that looks like this. 1, 2, 3, 4, 5, 6, 7, 8. And then all you're doing is filling in the spaces with zeros. Okay, so you should get 847 million, which is what we got for our previous answer. All right. All right, so that's all that is for that. Now, let's just say that we needed to write this really large number back into scientific notation. So how would we address this? Well, first of all, we need to take a look at where the decimal is located, right? Oops, and I erased that by accident. So let's go ahead and rewrite that. All right, so to rewrite this into scientific notation, we first have to locate where the decimal is located, and it is right here. All right, and so what do we do from there? If you need to pause the video, go ahead and pause the video. Okay, so what you're doing is you're taking the decimal point and you're going to move it until there's just 1 digit to the left of it. Okay, so it looks like this. 1, 2, 3, 4, 5, 6, 7, 8. Right, so your decimal point is here. So all you're going to do is take 8.47 leave off your trailing zeros, and you're multiplying by 10 to the positive or negative power. So I hope you said positive power, right? Because we're working with a very large number, and the power is 8, right? Because we moved a total of 8 spaces to the left, okay? So that's your answer for that one. All right, so let's go ahead and do one more example, okay? This time I want to use one with a negative exponent. Okay, so let's just say that we have 3.15 times 10 raised to the negative second power, okay? So what's really going on here, before I go any further, is that you're taking the decimal point and you're moving it 2 places to the left, all right? So let's go ahead and break this down so you can actually see what's going on. So we have 3.15, right? And it's multiplied by 10 to the negative second power. So we can go ahead and rewrite this as 1 over 10 squared, right? Or simply 3.15 times 1 over 100. Okay, so think back to the lesson where we covered multiplicative inverses and or reciprocals. That was the lesson on negative and zero and negative exponents. So go ahead and check out that lesson if you need a refresher. All right, so basically what we're going to do is take a look at the scientific notation that we have here. So we know that since our exponent is negative, our number is going to be between 0 and 1, not including 1. So technically, all we're doing is filling in 2 more extra zeros, with the last 0 being in a whole numbers position, right? So this is all we're doing, 0.0, and then we're just going to fill in the rest of our numbers of 3, 1, 5. So this is what I wanted you to see when I said that what's really going on is that you're taking a decimal point and moving it 2 places to the left. So let's take that same number. Let me go ahead and clear this out. So we have 3.15. Okay. And so what's going on is that you're taking this decimal point, moving it 2 places to the left. 1, 2. All right. And your decimal point is here. And your whole numbers position also has 1 extra 0. All right. So that's where this came from. 3.15 times 10 raised to the negative second power. All right, so you can see that this indeed is a really small number. Okay, so now what if we wanted to convert this number to standard notation or standard form? All right, so let's go ahead and do that. So what you're going to do is take a look at where your decimal point is, and you're going to count how many places the decimal point needs to move until there's just 1 digit to the left of the decimal point, okay? So in this case, we're moving it 1, 2. So we're moving it 2 places to the right, and there's just 1 digit to the left of it, right? Because we have to ignore these zeros. These are gone now, right? So we're left with 3.15 times 10 raised to the positive power or negative power. And I hope you said negative power because we are dealing with a really small number. All right, so that's all we have for this lesson. Hopefully it was helpful. If not, please go through it a second or third time. Sometimes it's not always clear on the first time around, but second or third time seems to really help a lot of people. All right, so I will see you in the next video. Take care.